Okay. I'm going to pick on Colson. Colson, what does the word difference mean?
Subtraction.
Subtract. So what's your answer on this one?
13.
13.
What?
Okay. Difference means subtract, right?
Yep.
Okay. The word difference means subtract. Okay. List the following squares. So let's see. I'm just going to, well, come on. 1, 4, 9, 16. One of the math teachers here, Miss Dayton, has a son who's 4 years old who knows these up to 8 squared. He can just rattle them off. So that's pretty cool. 121 and then 144. And then it starts to get a little more difficult. Caleb, what's the next one? 169. Okay. And then Luke, what's 14 squared? The cool thing about this is if you know 13 squared, you can just take these last two digits and switch them. It's 196. Okay. 15 squared is kind of a cool number. There's not really any rationale for it other than just multiplying it out and everything. Sai, what is it?
What?
15 squared.
Oh, 15 was 2. Oh, yeah,
225. Okay, 225.
Wow.
Now, if you have them all memorized up to 20 squared, that's really good. If you've got at least up to maybe 12, 13, 14, then that's nice. Some of those in between, like 16 squared, 17 squared, 18 squared, some of those are a little bit funky, but if you have those memorized, that's going to come in really, really handy. Along with perfect cubes up to about maybe 7 cubed or something like that, those come in handy also. Now, if I say 30 squared, even if you don't have it memorized, that should be pretty easy to figure out. Hannah, what's 30 squared? Oh, we're putting people on the spot here. Let's think about it for a second. 30 squared, I'd have 2 3s multiplied together, which would make a 9. And then the 0 squared, you've got 2 zeros, so this is going to be 900. Okay? So some of those things you ought to be able to recognize, but it's just a matter of seeing them, locking that away, and then you're in good shape. So we're going to add 2 more rules for factoring today, and we're going to do it in a little bit different fashion. Sometimes we call these special products. So the I can statement for today is I can factor difference of squares and perfect square trinomials. So we're going to add to our big long list of how we factor stuff, but we're going to do that at the end, and we're going to spot some patterns in the way we multiply binomials. So I've got these set up right here. So we're just going to go through and we're going to multiply and we're going to notice what happens here. So if I multiply the x by the x, I get an x squared. The x by the 3, I get a 3x. Then it's the negative 3's turn, so I get a negative 3x, and then I get a minus 9, because I got a negative 3 times a positive 3, so I end up with a minus 9. Now, just like always happens with binomials, 2 terms times 2 terms, we've got 4 terms altogether here. Okay? Dane, what do you notice about those 2 middle terms?
They're like opposite.
They are exact opposites. So when I combine those like terms together, instead of them combining to be something else, they actually cancel each other off, and we end up with only 2 terms. We end up with x squared minus 9. Okay? So those middle terms cancel each other out. They're exact opposites, like Dane said. So if we take a look at the next one, this one's a little bit more complicated, but you'll notice that the structure's the same. When I multiply here, I get 4m squared. When I multiply there, I get negative 10m. Then the 5 gets its turn being multiplied. That's going to be a positive 10m and a minus 25. And Lydia, what happens to those middle terms? They cancel out because they're opposites. So I end up with a 4m squared minus a 25. So I'm going to put a box around that. That's what happens when we multiply binomials that look like that. It's a little weird. Normally we end up with a trinomial. We combine the like terms and stuff like that. But in this case, multiply the 2 binomials, I end up with a binomial. I end up with just 2 terms. Okay? So when a multiplication problem has factors of this form, the middle terms always cancel to be 0. So we don't have that linear term, if you want to think of it that way. And the 2 terms that are left, take a look at them. They're always going to look like this. They're going to be a perfect square, like x squared, or like 4m squared. 4 is a perfect square. M squared is a perfect square. Minus another perfect square. 9 is a perfect square of 3. 25 is a perfect square of 5. Now notice this has minus right here. I'm just going to highlight that. The minus is not part of the perfect square, because if I square something, it always turns out to be positive, right? The minus is part of the pattern, not part of the perfect square. So if we've got a binomial, two terms that fit this pattern, then we can factor it really quickly. So here's what we're going to check. Okay, we've got two terms. Is the first one a perfect square? If it is, what's it a perfect square of? That's a perfect square of x. Does it end with a perfect square? That's a perfect square. It's a perfect square of 4. And is it a difference? Okay, we might want to check that first, actually, okay? Because if it's not a difference, then it doesn't fit this pattern. So this is the pattern of difference of squares. So here's what this would factor to. This actually factors to x minus 4 and x plus 4. It's always going to be two things that are exactly the same. The only thing that's different is one of them has a minus in the middle, the other one has a plus in the middle. Okay? So running through. Is the first term a perfect square? Yep. Second term a perfect square? Yep. And are the terms subtracted? In other words, is a difference? If that's the case, and this is the way we typically see this formula written, we just say a squared minus b squared. Here's what it would factor to. A minus b and then a plus b. Now, need you to listen. Most people do not teach it in this order. Most people will put the plus first and they'll put the minus second. So if you go to almost anybody else, checking a book or anything like that, they're going to say a difference of squares factors to a plus b and then a minus b. Does that matter? It doesn't. Here's why this is better. This is better because in the long run, we're actually going to teach you some things that we don't need to this year. You'll see them in the future. It's called a difference of cubes and a sum of cubes. If you always remember that if this is a minus between the two of these, the first one is a minus and then the second one is a plus, in the long run, there's some other things down the road that make them easier to memorize, okay? So I'd like you to memorize the difference of squares as if it's a squared minus b squared, it factors to a minus b and then a plus b. So we're going to do something kind of silly. Is that a perfect square? Yep. Of a. Is that a perfect square? Yep. Of b. Is it a difference? Is it a minus in between them? It is. So it factors to a minus b, first one minus the second one, then a plus b, first one plus the second one. There are the factors. We good? Okay, notice all of these have two terms. Difference of squares is two terms. So I've got a difference, perfect square of x, perfect square of 7. This is why it's so helpful to have all those memorized so you recognize them. So this is going to factor to x minus 7 and then x plus 7. We put a box or a circle around that. We're done. That's how cool and how simple the formula is. So for this one right here, Mason, is that a perfect square?
Yeah.
Of what?
3.
3 and an x. Okay. Crew, is that a perfect square?
Yes.
Of what?
2.
2. Okay. So Angela, what's the first one I'm going to write down?
3x minus 2.
And what's the second one?
3x plus 2.
3x plus 2. And it's that simple. We are done with that one. Okay. Jack, perfect square here?
Yes. Yeah. No.
No.
That was
Dang
good,
it.
boy.
Dang it. It's not going to work.
Come on, Jack.
No, it will.
Keely.
Did you pull out a 2?
Oh, there we go. Take a look at this. You can take out a 2. Don't forget rule number 1. Just because it doesn't look like it on its face doesn't mean it doesn't work. So we're going to take out a 2. I'm left with an x squared minus a 25. Now we take a look at it, and I'm going to ask Jack again. Jack, is x squared a perfect square?
Yes.
Of what?
X.
And is 25 a perfect square?
Yes.
Of what?
5.
5. So those are the two things that we're going to use. I'm going to go ahead and put the 2 out front before I forget it. I'm going to put a minus in the first one. I'm going to put a plus in the second one. Megan, what's the first one? X minus 5. And the second one would be the opposite of that. So x plus 5. We put a box around that. We're all set to go. Whoops. Any questions? Okay. Ooh, this one's a little messy. It's got an asterisk by it. Hannah, is that a perfect square? It is. Of what? To the second. Very good. She's right about that. And you can't take out any common factors out of this either. Okay. Luke, is that a perfect square?
Yeah.
Of what?
9.
And?
Y squared.
And y squared. Okay. Is it a difference if we got a minus in between these? We do. So this is going to be first one minus the second one, and then the first one plus the second one. D's got his hand up. Did I write something down wrong? Colson's got his hand up. Keeley's got her hand up. Mason's got his hand up. Yeah.
Couldn't you simplify more because 4 and 9 are perfect squares?
Okay, take a look at this right here. Perfect square of 2x, perfect square of 3y. Is that itself a difference of squares? It is. So this is going to be 2x minus 3y, 2x plus 3y, and then we're going to have, can you factor this? Is there a sum of squares? Okay, stop and think about this. Those middle terms had to be opposites. No sum of squares. We're just going to write 4x squared plus 9y squared, and there we go right there. Okay? Any questions? Okay, we're going to take a look at the last two. We're going to look at the easy one first. Take a look at F. Will that factor? Okay, there is no sum of squares. So no such thing as sum of squares. We'll take a look at y in just a second if we've got time. Yeah, I think we've got time. Abby, what do you want to do first on this one? Very good. We're going to take out the -3. So we get an x squared and we get a -9. And now we've got some factors. Perfect square of x and 3. So it's going to be x minus 3 and x plus 3. And then don't forget the -3 sitting out in front. If I were to answer this completely, what would I say right here?
No sum of squares.
No sum of squares, or we just say that is prime. Okay. Everybody good? Okay. Any questions? Okay, hold on. Don't switch over yet. Look up here. You don't have to write this down. You don't have to write this down. Watch. If I were to write this out, and a lot of times this is helpful, I could, if I wanted to, I could replace that missing linear term with a 0x. Because 0 times x is still 0. So I've changed the way it looks, but I haven't changed the value of anything here. It's a trinomial, though. Okay, Sai, is this an easy trinomial or a hard trinomial? Easy. So I'm going to break this up into two factors. I'm going to start with an x and an x. Mason, will you grab the door? And then I need two numbers that multiply to be -49 that combine to be 0. What are they? Okay, -7 and +7. Now, most people would say 7 and -7. If they get switched around, is that a problem? It's not. And when we correct this, I'm not sure how Miss Doty does this. Okay, but she probably does it with the plus first, but I'm not sure. Watch what happens if you try this. Okay, if you were to write this out as x squared plus 0x plus 25, this is why there isn't a sum of squares. I need some numbers that multiply to be +25 that combine to be 0. Like we talked about the other day, I need some numbers that multiply to be a positive. What do we know about the numbers? They'd have to both be positive or both negative. And if they're both positive, they'd combine to be a bigger positive. If they're both negative, they'd combine to be a bigger negative. There's no way they'd cancel out, right? So that's why there's no sum of squares. Okay, flip the page over now. Different pattern here. Every bit is cool. So if I multiply these together, something's going to happen. So you'll notice I've got this binomial squared. We took the opportunity to write it that way a couple of times. I'm going to write x minus 6 times x minus 6. If I wanted to be a little tricky and save some space, I could have just written it there. Okay, but I'm going to be on my best behavior writing-wise and see if I can fit this in here. So when I multiply 2 terms times 2 terms, I'm going to get 4 terms. I'm going to end up with x squared minus 6x minus 6x plus 36. X times x is x squared. X times negative 6 is negative 6x. Then it's the negative 6's turn, and we get this. And unlike what happened last time, they're not exact opposites, but they are exactly the same. So they combine to double up. They combine to be twice as big. So this is going to be x squared minus 12x plus 36. There's our answer on that one. And I am going to cheat on this one because I think I might need a little more space here. 9m squared plus 15m plus 15m plus 25. Because I'm squaring that binomial, I get this repeated pattern here. I get these middle terms that are exactly the same. So I get 9m squared plus 30m plus 25. I get that for a trinomial. Not a binomial this time, but a trinomial. Okay, so here's this pattern. We ready? Yeah.
Would you simplify b because it's divisible by 3? Wait, is it? No, never mind.
Nope. Plus we were just multiplying. Once we've combined like terms, then we're done. Okay. The first and last terms of the trinomials are, take a look at them. Every one of those is a perfect square. And before simplifying, the 2 middle terms are always the same. So that means when we combine them, instead of canceling out, they double up. And that'll make the final middle term, that linear term of the trinomial. So if it fits this pattern, then we can quickly factor it. So here's what we're looking for. Does it start with a perfect square? If it does, let's figure out what it's a perfect square of. It's a perfect square of x. Does it end with a perfect square? If it does, let's figure out what it's a perfect square of. It's a perfect square of 5. In other words, we could just take the square root. Then the middle term is a little tougher than the last one. Here's what we check for. Is the middle term double the product of the 2 square roots? So if I took the square root of x squared, I get x. Take the square root of 25, I get 5. If I take those 2 and multiply them together, I get 5x. And if I double it, do I get 10x? If the answer to those questions is yes, then it factors. So here's the deal. The only difference could possibly be that this might be a plus or it might be a minus. So if it happens to be a minus, it's the square root of the first one, which would be a, minus the square root of the last one, which would be b. Square root of the first one, which would be a. If it's a plus for a middle term, if it's a positive middle term, then it's going to be a plus b. So is the first term a perfect square? Is the second term a perfect square? And is the middle term those 2 square roots, if you want to think of it that way, multiplied by 2? Is it double the 2 of those multiplied together? If it is, it fits the pattern, and we can factor it really quickly. Okay, so if I take a look at this right here, perfect square of a, perfect square of b, multiply them together, that's ab. And then if I double it, that's 2ab. So the only thing I do is I put the a and the b in parentheses, and I bring this sign right here with it. So it's going to be a minus. And the only thing that would change about it, that entire thing, is we keep the sign of that middle. So if we take a look over here.
Hey, boss.
Yep.
Will you send Devakar Maram to the office? He's checking out.
I will send D to the office. Yes, I will.
Thank you.
Okay. All right. D called it. So, again, all we're looking for is, does it fit the pattern? We've got the A and the B over here. If it's minus for the middle term, it's minus in between them. If it's plus for the middle term, then it's plus between them. Any questions? Okay. So, perfect square of V. Take the square root if you want to think of it that way. Perfect square of 7. If you multiply them together, I often don't write this entire middle process out, but I'm going to do it on this first one. That's 7V, and if I double it, do I get 14V? V and 7. All I have to do is decide what sign goes between them. Same as the middle one. Okay, can I see a thumbs up, sideways, or down on this so far? All right, not too bad. Perfect square of 2x. Perfect square of 3. If I multiply those together, I'd get 6x, and if I double it, I get 12x. I get the right middle term. And all I have to do is, bring that sign down here. If the middle one's positive, that's going to be positive. Okay, Wilson, any ideas on this one?
The last number is a perfect square.
The last number is or isn't?
Is not.
Is not. Is the first one?
Yeah.
Careful.
No, it's not.
It's not. Ideas? Multiply. Do it the hard way. Multiply them together and get 196. Come up with numbers that multiply to be 196 that combine to be 28. It would work. He's right. It would work. But can we think of an easier way to do this, Dane? Take out the 2. Don't forget rule number 1. So that's going to be u squared plus 14u plus 49. Perfect square of u. Perfect square of 7. Multiply them together. That would be 7u. Double it. Do I get 14? I do. So this is going to be u and 7. Don't forget the 2 out front. It's a perfect trinomial square, and all we have to do is get the sign right in the middle, and there we go. Now, everybody look up here for just a second. Pause whatever you're doing. I know you're rushing through this. Okay. If I don't write the u underneath the u squared, and I don't write the 7 underneath here, and I don't multiply them together and get 7u and put a 2 in front of it, is that okay? Are we okay following that? Can we keep track of that mentally? If you want to show this work on every one, that's fine. Okay? All right, what about this guy? Starts with a perfect square, ends with a perfect square. Perfect square of r, perfect square of 4. That'd be 4r. Double it. Is that the right middle term? No. It is not. Give up? Mason?
We can still factor it like a normal trinomial.
Yeah, it's an easy trinomial. So just because it's not a perfect trinomial square doesn't mean that it doesn't factor at all. Numbers that multiply to be 16 that combine to be negative 10. R and R here. Smara, what do you think?
Negative 2,
Negative 2
negative 8.
and negative 8. Do they multiply to be a positive 16? Yes, they do. Do they combine to be a negative 10? Yes, they do. So just because it starts and ends with a perfect square doesn't mean that's the only way it might factor. Okay? So here's what we learned today. So I kind of did this backwards. We already know about rule number 1. We already know how to factor 3 terms if it's an easy or a hard type of trinomials. We've got those covered. We know if there's 4 or more terms, we do grouping, and we always want to include all the factors in the end, and we want to factor completely. Here's what we did. This, for now, listen. For now, the only way if there's 2 terms to factor is going to be difference of squares. Again, the minus here means we put a minus in between the first one. Then if there are 3 terms, this is pretty quick, isn't it? This little pattern makes things that look awful turn out to be pretty easy. So if you do notice that it starts and ends with a perfect square, this is a great way to go. Okay? If it doesn't fit that pattern, then we can always graph it or factor it using the easy trinomial technique or the trinomial grouping technique. Everybody good with that? Can I see a thumbs up or down now? Nice and high? All right. Okay. Sounds good.